Hello and welcome. This is our session on Towards AI. With me this evening, I've got a guest facilitator, so we are really excited to bring to you all some information that will be helpful for you to put to use immediately. My name is Diana Honish-Haig, and I am the Director of Retention for our online master's degree programs at the University of San Diego. And here with me this evening is Louis-François Bouchard. Louis is the co-founder of Towards AI, a leading community and company helping bridge the gap between AI research and real-world applications. And he's also the author of the best-selling book, Building LLMs for Production. So with a background in systems engineering and a master's in AI, he's worked across academia, startups, and education, creating the What's AI YouTube channel to make complex AI topics accessible. And today, he focuses on building practical AI solutions and teaching others how to develop reliable, scalable, LLM-powered products. So please join me in welcoming him.
Thank you. So yeah, I will try to make this presentation as applicable as possible. And mostly, I will do that by sharing how we at Towards AI tackle our projects with our clients. So as Diana mentioned, we really focus on education and we build courses and trainings for the industry. But we really want to remain at the forefront of the technology. So we do that by still taking clients and by actually working in the industry for clients. And so I felt like this was a good opportunity to share how we do that, how we tackle projects with clients, and how we decide on the type of architectures we will build for client projects in this new agents era where we can make tons of different decisions that I will talk about. I'll also quickly introduce myself shortly, but first I just want to share a few points on why it's important to learn to build with language models. And if you are joining, obviously, I think you already know these points, but I like to just remind people listening, just because, just for these few reasons. First, language models are now super viable and they provide real value compared to AI systems back in 2016 or 18, where we could generate images, but one out of thousands, hundreds, if not thousands and it would be like a weird looking dog. And now it's really, we can accurately generate images, but also use functions and do tons of things other than just generating words. So they can be linked to existing products and linked into existing software. Another reason is that LLMs are not really that good out of the box. They are super powerful when they are integrated into applications and when that's done well, when we mitigate hallucinations and other errors. But out of the box, they are just systems that take text and generate tokens or other text. And we cannot do that much with such a system inside an application. They obviously bring a competitive advantage to any applications when they are implemented right. And one of the biggest factors is that you don't need huge budgets anymore to implement them in your application. We have big companies like OpenAI, Google, and others that train these models, and we can simply leverage them and build around them so that they are even more powerful for our own domain or our own application. And fortunately, any software developer or even any person can use them in applications with some upskilling and some practice, which is our goal in teaching. And this upskilling or these new skills are the AI engineer, what we call an AI engineer. And it's basically the AI engineering skill set where it sits in the middle of the ML engineer or ML researcher that trains these models, like the people working at Google and Meta and OpenAI training the Bayes language models, and between, on the other side, the full stack engineer, the regular developer that creates the applications we use. The AI engineer is just basically the bridge between the two creating the toolings and the infrastructure around the language models and integrating them into existing applications. So that's the focus, is to build around language models, not necessarily to train them, even though we can learn to fine-tune them, which is way easier to do now than it was before. And the core competency to learn is to balance everything around language models, the cost, the latency, the different models, the tools that we can use, etc. And just as a side note, who am I? Diana introduced me quickly, but I just wanted to mention that I was a PhD student as well back 2 years ago, and I decided to quit to focus on towards AI because what I was learning and doing in my PhD was very disconnected from what I was doing in the industry at a startup that I was working at. So it was called Design Stripe, and it closed since. But still, I saw how different it was to work in the industry versus academia, and I really wanted to help people learn what I had to learn by myself. So that's what I've been doing since then, building towards AI, where that's our core mission, to make AI more accessible. And we've shared tons of free content, videos on the YouTube channel, articles on the Towards AI blog. We even created the biggest Discord community in artificial intelligence, and we have multiple newsletters in the AI space. And now we recently, I think exactly 1 year ago, we created the Towards AI Academy, which is our new learning platform. And we do industry coaching, trainings, and development for companies. So, and today I want to talk about what we do with companies and what we take from that to our Towards AI Academy to teach what we build, or teach what we ourselves learn. I will start with the AI engineering problem, just to introduce the recent agent era, and talk about the differences between workflows, agents, multi-agents, and how we decide between using each type of architecture. I will then walk through 2 projects that we actually built and are still building at Towards AI, one of a single agent architecture and one of a multi-agent architecture, just to show how we make our decisions into the architectures and the whole process of such projects. So first, the AI engineering problem space. Well, as AI engineers, we have constraints that govern all our decisions. These models are paid to use, so there's a cost per task, and they can be very high if you use multiple agents that communicate together, exchange constantly. There are some latency requirements if you integrate language models into applications or agents into applications. There's a quality bar to maintain because nobody will use a bad application. And for many companies, especially in Canada where I am, a lot of them are conscious of data privacy and they don't want to send their data everywhere. So that's also something you have to keep in mind, sometimes requiring local models or just other alternatives. And the AI engineering stack to tackle all these different constraints are mainly the tools, memory that we can add to a language models because they don't have memory by default, some kind of retrieval system, we also call that RAG, where we basically will just fetch data from a company from our own data to better answer the user requests. And we also manage orchestration, reasoning, build evaluations to know what we are doing. So that's the whole stack we are playing with. And we have a spectrum of solutions that we can use, which goes from the less complex, which is basically to just use an LLM and prompt it, to building workflows, then agents, and finally, multi-agent systems that are super complex. And so I will mostly focus on agents, and I really want to talk about the difference between workflows and agents, because most of the clients that come see us want to build many agents that do everything, and it's rarely the best decision to make. As we all know, 2025 was the year of agent. Everybody is talking about it and implementing tools or things for agents. 2026 will be the same thing. And that's because, as I mentioned at the start of the talk, an LLM is not enough on its own. It just takes text and generate the next token. It does that in a loop to generate a lot of tokens to finally have an answer. And with that, you cannot do that many things. So we want to augment language models with different things, like with data, for example, through adding retrieval, with tools to do things like using a calculator, looking on the internet, running code, or still to add memory to be able to sustain a conversation and go forward without forgetting everything. But still, all these implemented into language models are not agent yet. Most of the systems we build, even including tools, memory, and retrieval, will actually be more of workflows with tons of prompts, conditions to follow, some loops, and functions to use, which would be our tools in this case. And a workflow can be super complex, can do many things. It can do many things. We can do what we call prompt chaining, to just basically call the LLM once and then another time and another time to easily break a complex task into simpler tasks and reduce the latency or the complexity of a task to achieve it. We can also call an LLM in some conditions, otherwise call another or call a tool, which we do that using a router or an orchestrator. And that can be useful to use sometimes a smaller model, sometimes a larger, or some other type of applications like classifying something, or perform other tasks without LLMs, like using tools, etc. So we can do that conditionally, and we can even do that in parallel to be more efficient, which brings also a new technique a nice technique that is called majority vote, where we can just send multiple questions to different LLMs or the same LLM multiple times and aggregate the answers to then select the answer that was the most frequent in all responses. And we can even add loops with evaluator or, for example, validators to evaluate and measure outputs and provide feedback automatically. Most people call this LLM in a loop, but this is still not an agent. And so when does it become an agent? Well, even if it's a bit blurry, most people say it's when you have an environment. So when the agent or the LLM acts in an environment and can react to it based on the environment feedback. More specifically, this means that the agent will autonomously decide what it must do to achieve a goal, and will plan and execute the plan, and then react according to the environment, what it says, and what happens in the environment. So it will adapt based on the responses, and crucially have a plan and execute it. Hopefully, we will have also human in the loop to verify that plan and ensure everything looks fine before executing. And just to give that an example, to give a clear example, an agent could be a system that will go make purchases for you. And in this case, the environment would be the internet. And it could make a plan. If you want to buy a computer, it will ask for all the specs and then decide what website to check for each spec, and go on the website to purchase each item. And that will be the plan, and it will execute it. But if it opens a website and it's down for some reason, or it's closed since last time it knew about the website, it won't crash or skip this step. It should react to it and restart its plan, and change the plan to then continue the task and succeed at the task, even if the original plan didn't work out. So that's typically what we would call an agent. So something a bit more similar to a human compared to LLMs with tools and loops that are all clearly hard-coded in a workflow or even in prompts with clear conditions that we know in advance. And when to use or not to use an agent, in short, we always want to use the simplest solution possible at first. It's the rule for coding, and it's the same for artificial intelligence. If we can not use any LLM, it's better to not use any LLM. And typically, for the agents, we want to start simple with just prompt engineering, so testing a model, even on ChatGPT or whatever tool. Then we can implement things like retrieval tools, fine-tune models to try to be to make it work. And if it still doesn't work, this is where we can consider agents when we need more variability in the tools. Like, for example, when we can create many different tools, which in this case are functions. So can be to use the internet, to scrape a website, to use a calculator. When we have these tools, but we don't exactly know when the model should use them, we just list the tools to the model and we ask it to decide by itself. So when we need more variability with the tools. When we need autonomous decision making, so something a bit more not conscious, but more autonomous, or where the problem is too complex to have a hard-coded solution with clear steps, as in a workflow. Also, we need bigger budget, just because the more agents we have, the bigger the price it will be to generate an answer, just because of the back and forth and all the tokens that will be generated. And one good consideration to make an agent is when the response really needs to be tailored to the user, and we don't exactly know who the user will be. So if we create for example, a chatbot to generate marketing content, if the user are from different companies, we definitely want the marketing content to be tailored to the user's company and not relatively general. So that would be a good use case of an agent. Anthropic also have a nice slides on agents, if you should build them or not, which they released earlier this year, I think. And it's basically if the task is complex enough and if it has value, because it's expensive to run agents, you should try them. Obviously, if the task is doable, you should also consider using agents, else you may want to reduce the complexity and dividing into subtasks. And the important one is if the cost of error is low, which means that, for example, with our agent that was going to buy our next computer, the cost of error is quite high because it can buy an expensive GPU that doesn't have any guarantee or whatever. It will cost you money. Whereas, for example, if you have a coding agent, if the code doesn't run, you will just have checks or a human review the code before pushing it to production. So the cost of error is quite low. It won't damage the company or anything. So it's a good case of using an agent safely in this case. And what is an agent according to the community? We have a lot of different definitions, but most people agree that it's basically what OpenAI says with an agent is a model with instructions, tools, and runtime. In this case, runtime is pretty much the same as environment. And in our case, as AI engineers, what we really want to focus on are the instructions and the tools, because the model itself, as you know, evolves very quickly. They are always beating one another, and ultimately, if we look at one timestamp, like right now, they are all quite similar. The best models are out there, from whether it is Google with Gemini or OpenAI or Anthropic. They are very similar. And so it's not really a game changer to change from one model one model to the other. And where we can bring value as the implementer of these models is through the instructions and the tools that we give them, that we build for them. But all these, the instructions and the tools, all lie within the same space, which is the prompt, the content that we send to the language model. So they all sit in the context window, the length of tokens that we can send to a model, which is quite constraining because we send it a lot of things. An agent context in this case is made of obviously the system instructions, the system prompt, and the user instructions, the user prompt, which in the case of ChatGPT, for example, the system prompt is to be a useful assistant, and the user prompt would be your question. There will be the tool definitions in the prompt as well, so how to use the tools, what to send as variables, and what it will get back. You could have few shot examples, so just trying to teach it on the fly how to do different tasks or how to do the task that you want it to do. You could have retrieved data if you needed to have data from your company to best answer the user. You may retrieve this data and add it to the prompt. And you could have entire conversation histories with of the chat with the user. If the conversation was long, it can be quite big. So at each of these steps, the context grows and the performance degrades. And the performance degrades because of something we call the context rot, which happens far before the limits that the companies say. For example, Gemini with millions of tokens context or hundreds of thousands in the case of OpenAI and the others. The performance degrades much before that, around 100,000, because of how we train them to handle long context. We actually, what would be good for long context would be to, for example, send a large book and then ask everything about Robert from that book. And to best answer the user, the model should know about when we talk about Robert at page 2, page 10, page 100, at all the different places. And that would form the best answer possible. But that's not what they do because it's really expensive to build such a data set, a large data set like this. And instead, they will just take a large book and insert a random fact in it and try to ask the question and retrieve the fact from the model. So the model is just thought to find one fact in a large corpus, which isn't really understanding the whole corpus that we send it. And so even though we are maxing the benchmarks, there's this problem of lost in the middle where the model loses information because it focuses on very specific facts rather than the context as a whole. So we need to be careful of that. And our main role as AI engineers is to manage this context budget. And there's one rule to keep in mind is to keep the context as lean and as relevant as possible. There are many techniques to do that can help do that. I will just quickly go over them because I want to focus on one. You can trim, so just discard the older messages in a conversation, for example. You can do summarization and condense interactions or data that you send it. You can do selective retrieval to reconstruct the discussions with just the crucial bits. But most interestingly, you can also delegate, just like in the real world, you can delegate tasks to tools and to sub-agents with each their own context. So you basically elevate some context from the main agent into either the tools or other agents. But now, when do we do that? When do we delegate to tools versus other agents? So when we stick with when to stick with single agents, well, it's relatively obvious. It's when the task is very clear and straightforward with one domain. You always need to have the whole context. So, for example, if you have a programming agent, you just always need the code in the context window, and then you generate new code. You don't have to do other things that are unrelated to the code that the user gives you. So that's a very good example of a single agent problem. Or, for example, an agent that generates marketing content. It's always about marketing content. It won't be different. So the difficulty, the complexity is very similar. The domain is always the same. So it's logical to have one agent. And there are some other examples of that. Also, it's important to keep one agent if, all the knowledge is required to achieve the task. So for example, with the generating marketing content, you may keep it as one agent because you need to have all the user data and the conversation with the user to be able to generate the best marketing content possible. You cannot just split the content into multiple agents and expect the same results because it won't have the global context to best help the user. Likewise, if you expect your workflow or your system to have not many tools, like less than 20 typically, then it's manageable to have a single agent. Otherwise, since tools are used in a way that we describe them into the prompt and describe how to use them, they take a few tokens. And if we have many of these tools, they take many tokens. And typically, if we can manage up to around 20 tools for one agent without degrading performance. And then it may, if we have many more tools for one agent, it may just call the wrong tools or use the wrong variables, etc. There are a lot of problems that can happen. And obviously, it's less expensive to have just one agent, and it's less complex to implement compared to having multiple agents. So on the opposite, when do we have multiple agents? Well, it's exactly the opposite. When the task is more complex and you see how you can split it into subtasks where you could have smaller, more focused entities or agents in this case to be able to solve each of them. Or if you have too many tools, so here typically over 20 tools, and obviously, if you plan to integrate other agents, like, for example, a booking service from a flight company, an agent from a flight company to book services, you are already in the multi-agent space just because you are using their agent. So that makes sense. And if some tasks are not interdependent, so if you see that you could, for example, have a research agent that needs to learn about RAG, you want it to learn about RAG, it could do a research about vector databases, but at the same time, it could do a research about keyword search because they are not really related and it can learn about both at the same time. So it can be more efficient, but you need to integrate both into two specialized agents. And this is just one example to show this exact process. We could have, for example, a lead agent in a research system where this lead agent could use tools and other agents to do things, which is ideal to maintain the full context and to control the workflow for best consistency and best understanding. And in this case, the lead agent could use research sub-agent to execute search on, as I said, keyword, and the other on retrieval methods and etc. to all do different searches in parallel and gather the response back to the lead agent, which would have the whole context and be able to not have information silos, which happens when you have sub-agents, which can happen when you have sub-agents where information is basically lost inside one of the agent and it doesn't get back to the lead agent. That can happen in multi-agents. So having an orchestrator like this can help versus just an army of small sub-agents. And there's a trade-off to using multi-agents. Obviously, it simplifies the context because you divide it into multiple entities. You can do prioritization just like I described. You can have specialized agents. So typically, it can be much more powerful if you need to do a lot of things. You can have specialists at each thing or a specialist system at each thing. But there are some cons to that. First, it's more expensive because it just uses way more token. Each agent needs to share the context to the other, and it's just generating and sending way more tokens. There's typically more latency because of this same interactions. it's typically less reliable and more complex to implement just because there are more things to do from us, the humans, so more potential errors. And there's a main risk of the information silos that I mentioned. So that's a bit, that's all for the theory. I do have now two projects, two real example projects that we built at Towards AI and how we tackle them. And I go through them with a ton of questions that we ask ourselves, because that's always how we deal with clients. We just ask tons of questions and then we discuss together and we ask questions together just so everything is clear and everyone understands what's the goal and what to do. I might go over the first project and then quickly over the second because the questions are very similar and highlight the different ones. So I might skip some slides, but I will mention it. So for the first project, it's well, that's a spoiler. It's a single agent, but I will still go through the question. We had a client that had a CRM, so a marketing automation platform, which basically is they have clients of their own that want to manage the communication with their own users through whatever system, emails, app notifications, SMS, and automate this process. And they reached out to us because they wanted a way to automate the marketing content generation for their clients that would be easy to use through a chatbot. There were some constraints from the start. Obviously, it needed to be cost effective. It needs to be reliable, so it needs to not crash. It needs to follow the user styles and their data, because marketing content that isn't personalized won't really work. And it needed to be able to generate code lines in their proprietary coding language, because whether it is emails, app notifications, or SMS, in the CRM application, it was displayed with their own HTML-like coding language. So our chatbot needs to answer with tags similar to HTML in their own language, which was an added complexity to consider. And so the first question we always ask ourselves is, what exactly is the client's goal for this project? What do they expect us to deliver at the end, and how can we best help them? Because oftentimes it seems very simple and very clear, but it really isn't. Just like the description that I gave on the previous page isn't enough. We actually need to know much more to send a proper proposal and expectations of the work to be done. And so we did a small analysis, and the analysis here is basically asking a lot of questions to the client and then discussing internally, and asking again questions to the clients, and just ensuring we really understand everything that they want. And in this case, I already mentioned that, but they wanted an AI system to interpret automatically what their user wants and generate personalized multi-channel campaigns or content based on what the user wanted. They wanted proof of concepts covering up various scenarios that they already came up with. And so it's not there's a difference here where sometimes they actually want us to build a product inside their application or just build a product. Here, they really just wanted proof of concepts because they have developers. And so they just wanted to know how to do the scenarios that they had in mind. They had a dozen scenarios in mind of things they knew their users wanted to do. And they wanted to know how they could do that in Python. And then they would themselves integrate it in their application. So they needed someone to evaluate different architectures, tools, models, and strategies to best solve all these 12 scenarios in one system. So that was our goal. And they also wanted ongoing knowledge transfer during the proof of concept. So now we still are working with them, and we have a weekly meeting with them to share the progress and explain our decisions, because that's what they wanted. They really wanted to learn how we work. And finally, I already mentioned that, but the output must follow the message template format in their own HTML-like language. So we couldn't really have known all of this without asking many questions. We could have assumed it would be a full project development with deployment and in production, etc. And we would have charged way more than just a proof of concept. And they would probably not have accepted our offer just because it would be more expensive, but that would have been because we didn't clearly understand what they wanted. And so what we did was to put 2 of our AI engineers on the project with obviously sufficient skills to do the project. And we sent a proposal and plan of how we will cover the 12 scenarios that they gave. They also wanted to add more scenarios in the future, so we had to keep that in mind that the project will evolve in time. So yeah, we need to keep that in consideration when we build. It needs to be scalable. So the first real question that we asked ourselves for this project was, what architecture should we use? Should we use a workflow, a single agent, multiple agents? Well, we again did an analysis, and we discovered through reading all the 12 scenarios that they sent us that the tasks there are always quite similar and always sequential, where the agent or the LLM will just make a plan, generate the content, validate it, and send it to the user. It's always quite similar, always marketing content. And for LLMs, in this case, the reasoning is quite consistent. It's always the same complexity for the task. And the tool count, after analyzing the 12 scenarios, seemed to be manageable. We estimated around 10 to 15 tools to use. We need, obviously, validations for the tools and also the content generation, just because of the constraint on code generation, and just to ensure the quality of the work produced. So we considered other alternatives like building a workflow or having multi-agents, but ultimately we went with having one agent with a lot of specialized tools, and we can later upgrade to multiple agents if needed. In this case, we would just have one main orchestrator or one main agent with tons of tools that look like this. Basically, we have, for now, 3 main categories: tools to go get data, tools to generate different formats, and tools to validate the syntax, the length of the messages, etc. And how should we architect those tools? How should we implement those tools in the application? This was our next question. Well, as we want the agent to focus on writing and generating the content and reasoning, we needed the tools to do the rest, to validate, to retrieve. And as I mentioned, they needed to be modular and reusable, mostly because we will add scenarios in the future, and we don't always want to build a new tool or even add an agent for a new scenario. Instead, just like in regular coding, we really want to build tools as general as possible so that we can use them in various scenarios and simplify the work. We also wanted a standard way to expose the tools so that we can always use them later easily, and each of the tools have their own prompt and logic, and the agent just orchestrates or uses them. So there are a few alternatives for that, but we decided to go with the popular MCP library, the popular MCP servers and clients, using FastMCP in this case, following the principle of thin agent and heavy tools, because we really want to have the tools do the heavy lifting, for example, our context budget, but also just to simplify the work in subtasks. And obviously with MCP, it's really useful because the tools can be used across different IDEs and without rewriting the logic. So it's a really powerful and promising system to use. The next question was, how do we orchestrate what framework do we use to orchestrate our whole system? There are, again, a few options that you can all take and that have strengths and weaknesses. Our decision in this case was to use LangChain, Loop, and MCP tools because the other tools are a bit over complex for nothing. And doing everything from scratch will lose a lot of time. It would be the preferred way if we really want to own the IP, if the client really wants to own the IP. But here it's just proof of concepts. So it's much easier to go with something that has a lot of pre-built integrations. So we decided to start simple with LangChain and upgrade only when we needed to upgrade. Next, what model should we use for each of these steps, for the generation, the evaluation? Well, typically we like to test different models, and we even like to use different models at the same time. We do that with OpenRouter typically, which is very powerful, and you can do easy A/B testing between models. But the client didn't like the ID because they really wanted to they were really concerned with data and really wanted to focus on one provider. In their case, it was Google. So we decided to use Gemini models. And typically, we just use the best models for the most complex tasks and the smaller models for simpler tasks. We just build evaluations to know if the model is good enough or not. And we use the cheapest that does that has the power to do what we want to do. Next question was, do we need to add data? Do we need to retrieve any kind of data? And if so, how do we give it to the language model? Well, yes, we needed to retrieve data because the user might send internal documentations or examples of how it wants the content to look like. And we need to base the system on that. We also, as the CRM's perspective, may retrieve structured records. So like, for example, the user names to send custom notifications. And in this case, the structured records would be returned as rows through SQL queries, and the RAG will return the short snippets, the chunks of text that we retrieve, and they will both be sent to the context of the agent. And our tool to do that is not really important. We decided mostly to use the ones that we knew that are easy to implement and very powerful, especially just for proof of concept type of volume. And we used LlamaIndex to combine all of this, which is pretty standard. A pretty standard choice. We also really like, just to mention quickly, the OpenAI text embedding small model because it's a very small and efficient text embedding model. But you can use also open alternatives, and there are tons of others out there. We just decided to go with this one because we are used to it, and it was fast to implement. Next question is one of the most important. How do we ensure generation quality? Well, the solution was to build validation loops. So I'll just skip to the example. Basically, if the agent generates a message, we will have validators in place to check different conditions like the maximum length or at all if the code is running, like the HTML-like code, just to ensure that it works. And if all the validators checks work, we will send it to the user. Otherwise, we will regenerate, try again, and repeat this loop until we don't have any errors. This system looks like this. It's very simple. We just have one agent that uses tools and replies to the user. And so I will go over the next project with a very similar process of the type of questions that we ask ourselves. But I will go a bit more quickly because it's, again, very similar tech stack. I will just highlight the differences. Here, the project was actually internal. It was for us. We wanted an end-to-end technical article production system. So basically, the goal was to take a topic, give it to the system, and have the system do a deep research online or through sources that we give it, and write a ready-to-publish article, technical article or tutorial, or even a course lesson. And then the second goal of that is to create a course teaching how to replicate the system. So we actually teach how to do that in our courses. And the main challenges here are first, hallucinations, both in research and writing. You don't want to fake cite sources or to generate false things. We also have what we know as AI slop in writing. So it's the M dashes and the delve in and all the terms that look generated that we don't want. We also must maintain a high quality of writing that is hard to do with consistency with language models. And we really want to the generation to look like our writing style and adhere to the requested format. In our case, it's technical tutorials. So sometimes there are code blocks, sometimes there are images, and sometimes it's text. And these images and code block are super important to understand the concept. So we really want the agent to be able to do each of these different things, different formats, not just generate a text article, which is very hard to do with just one LLM call to have a very complete tutorial with images, graphs, references, code, etc. And obviously, we want to incorporate human feedback because writing is extremely human. And if we want to create a good course, a good lesson, a good anything, we need a human touch with our style and our decisions. So we need the best ways to implement this in our system. So again, we have the first type of question of trying to understand what we really want our project so that we know what we want, but also everyone from our team, because we are a team of around 15 AI engineers, and everyone working on the project needs to understand what we want from that project. And so we did, again, the same type of analysis of just clarifying everything that we need. And basically, it's just like we need a cheap and fast, trustworthy system that generates articles, in short. And even though it's an internal product, we want it to be scalable and deployable because we want to teach that in the course where we will teach how to replicate this project. So it's a very important thing to us as well. And the first real question is, should it be a single agent or a multi-agent? Here, I think it's a bit important to highlight that. And the analysis is that there are two parts of this project. First, when we give a topic to do an article about, we first want to do a good research about the topic. And that's really exploratory. The system needs to look online, then digest the information, come back and go for search for more information. If it sees it lacks something, then interact with the user to see if it's fine and go back to research more, etc. It's a very flexible system that needs to react on the environment. On the other side, writing is much more deterministic. We always want a technical article in this case, so it's always the same type of format. It's always in our style, the user style. And it's really much more like a workflow pattern that we need where we need to mostly restrict the LLM to not generate AI slop, to not hallucinate. So we mostly want to make it focus on one specific task and not deviate. So it really looks more like a workflow. So there's a conflict where research needs flexibility, but writing actually needs constraints. And our decision, obviously, here it is to split the system into two systems, which we call a research agent and a writer agent. But do we need some kind of orchestrator, as I showed earlier, to manage both agents? And do we have to separate these agents, or can we keep them together in the same folder when we talk about the code? Well, it's not necessary to always have an orchestrator. It really depends on the task. In our case, we first created a very suboptimal proof of concept to just use and see how we use it. And we discovered that most of our team used the research agent and the writing agent together, one after the other. We didn't really iterate with the research. Once we were satisfied with, if we weren't satisfied with the writing, the end article, we would restart the whole process or restart just the writing agent. But typically the research aspect was pretty easy to nail down and to have good enough. We didn't have to restart the research, especially because we already did implement user feedback inside the research process. So it was already very good. And as I mentioned, the only iteration we did was with the writer agent itself. So typically the process is just to run it from scratch, research agent and then writer agent, or to iterate with the writer. And here the two agents work on the same artifacts that we call, which is basically we start with an article guideline, something basically where we write in a file everything we want from the article. So I want a tutorial on RAG. I want it to be written in my style. I will give some examples, etc. And we give that to the research agent. The research agent will make its research and create a document from it. And we send this new research document and the guideline to the writer to have the final article. So they are all very dependent on the same type of file and need to communicate together. The decision is to separate the two agents and run them sequentially without orchestration, just a very simple script executing one after the other, and keep them in the same project because they need to access the same files and send files one to the other. And also, it has the benefit that it's much better for AI-assisted coding because it's in the same repository. So the coding agent has access to both. The next question, I will now go a bit more quickly about these, is again that we needed to really understand what we wanted. So here is just a list of things that we wanted the research agent to be able to do and how to do them. We just clearly defined them. And then we asked other questions based on these things to do. So for example, it needed to scrape content and to do web searches. But those are two very different things. And we don't want to reinvent the wheel and code everything from scratch. So we just used two existing solutions, Firecrawl for scraping web pages and Perplexity for doing web searches directly, because it's exactly what we wanted. Perplexity gets precise answers and citations from global Google search, and then we can scrape using Firecrawl if we want more details on some of these websites. We also needed to manage YouTube videos, and TLDR, we use Gemini again here because it's very powerful for videos. You can actually send links to videos and it will send you the transcription and describe it, which is super convenient because typically you had to download the MP4 file, then run the transcription and describe it. So it's really cool to have Gemini handle everything by itself. Likewise, we had a problem with GitHub because we needed to access private repositories of the user. So we cannot just scrape the repositories since they are not publicly accessible. And instead we use git ingest, which we can provide the user GitHub token and access the private repositories. We have a few other questions, the same as I described with the single agent project. So what kind of library framework we used? We again used MCP and FastMCP here. The setup is very typical for our projects. We use Python, UV, which is a project manager to manage dependencies very easily, and obviously GitHub for collaboration. The model we use, again, is Gemini, just like the other project, but here's for a different reason. It's because Gemini has a free tier, which is very interesting when we want to teach our students because they don't have to pay to experiment. And so we always prefer to use Gemini in our courses and course content So we decided to go with that, but other providers would be okay. And you mainly just have to keep into account the cost and complexity of the task to either run a more powerful or less powerful model. There are a few other questions. The relevant one is how to communicate with the user. We can do different things. Here, we decided to mention it in the prompt of the tools themselves. So somewhere in the tool, when the model executes it, it will pause and ask the user and wait for its response before continuing. Then we have the same things for the agent, the writer agent, so how it should behave. Then most importantly here is how do we validate the text that is being generated? Well, we created rules that it has to follow in our style. So just writing, typical writing rules and personal writing rules. And we save them in markdown files that we call profiles. And then for each of these rules, we ideally would give a score from a 0 or 1 if the rule is respected for a specific section of the article. But that was not sustainable for the dozens of rules that we had. So instead, we decided to do that just for a critical subset of rules and check against the rest of the rules just with one prompt with an LLM validating that it was there or not in the generated content. Then same questions, library. Here we decided to go with LangGraph because it's an agent, but the function API because it's less boilerplate and less annoying framework-specific objects compared to the Graph SDK library. But anyways, it's not. We could have used other things. That's what we went with. And again, model, we used the best one with the Google Suite, so Gemini 3 Pro here. And it looks like this. The system, the writer system looks like this. So on the left, we have the article guideline that we write, so what we want our article to be, and the research file generated by the research agent. We send that to the writer agent, which is here the orchestrator. It uses tools to generate images, code, and other sections. Then it finally creates the article, and it reviews and it loops like that to have the end article. And how, I just have 2 more slides on the questions here, but how does the writing agent communicate with the user? We created MCP tools that we can use easily in Cursor and other development systems, IDEs, so that we can generate and edit articles easily. And the agents, as I said, communicate together via just a simple script. And they are also exposed as MCP servers, so we can use them anytime we want. I had other slides that I will skip because those are our insights and other questions, design questions that we ask ourselves with the decisions that come with them. And basically, I will skip them because that's actually all that we teach in our courses. We teach to make the best decisions possible and to know what to do in which scenario and be able to do them. So that's the small upskilling part with Towards AI that I want to share, and basically just share our learning philosophy and what our courses look like and why we exist. Basically, because of my story with the PhD that wasn't really satisfying compared to what was needed in the industry and in the startup world, our courses are super practical. So they are all about building projects, hands-on learning, just doing things that will be done by other companies. We keep our courses continuously updated, which is very hard to do in classical courses. We also provide lifetime access. It's not a subscription and you will lose the course. You pay once and you have it forever. Obviously, they are online, so it's self-paced and you do them whenever you want and at the rate you want. And you earn a certificate for any of our courses that you do when you complete the final project. Obviously, I will go quickly over that, but it's not just, I just want to be clear that it's not just you sit and you watch videos. It's actually courses to do things. We want you to code, to write lessons. We not to write lessons. We write the lessons, but to read lessons, see videos, and code through notebooks, but also through real projects with GitHub repositories that we give the template and help you to build a real final project. So we have all that in all our courses, which are basically split into two pathways. The one that is most interesting to you is the AI engineering pathway, which is actually where we teach to build with language models. And there's the other pathway, the one for any worker, where we teach to best use the AI systems out there and understand how they work and everything that is non-technical, quote unquote. So I'll focus just quickly on this pathway because we currently have 3 courses for different backgrounds, depending on your background. The first one is the main one that I think everyone should take. It's called the Full Stack AI Engineering. It's a very big course. I wrote 60 hours, but I think typically it's more like 80 to 90 hours. It's a very long course with more than 90 lessons now, and a final project where we help you build an AI tutor, in this case, your own AI tutor. But that's for people that already are quite familiar with Python. So if you are not familiar with Python, we have a course for that where we try to teach Python programming, but in a different way. Here, we try to teach it specifically for AI engineering and in a way that we teach to best use language models and agentic coding to help you, but not to replace you, to do the work for you. We really want to teach to best leverage these language models in your work. And finally, on the opposite side, if you are already an experienced software developer and just want really the quickest crash course to know everything about language models and how to make your next decision, we have our only video-based course. It's the 10-hour LLM fundamentals, where we basically assume you are a professional software developer, and we go through the whole LLM stack to know and to allow you to make decisions and kind of become the AI engineer in your company. And obviously, we have bundles for combining these offers to have cheaper prices and all. And just to mention, we have a 30-day money-back guarantee. If you don't like the course, you can just email the support, which is me, and I can refund the course at any time. So please do check out academy.towardsai.net, which is our course platform. And we also, as I mentioned, have tons of free content online on YouTube, our newsletters, our blogs. So feel free to upskill there as well.